Hello, my name is Gao Kailong and student ID is 133021015. Today I would like to introduce a towering feature in science who bridge east and west. Dr. Yuan Li. Dr. Li was born in Hsinchu, Taiwan, and is the Nobel laureate in chemistry from 1986. He is the first Nobel Prize winner to have grown up in Taiwan, which makes his story particularly close to me. I will share the journey of his legendary life from a curious student in Taiwan to a world-leading chemist, and finally a dedicated academic leader who returned to serve his homeland. Dr. Li earned his bachelor degree from National Taiwan University before pursuing his PhD at UC Berkeley in the United States. His brilliance later led him to collaborate with another scientific pioneer, Dudley Hershbach, at Harvard. His Nobel Prize winning work in 1986 focused on chemical dynamics, specifically analyzing the cross-molecular Bing's apparatus image, trying to observe two tiny molecules colliding and reacting. It is an incredible difficult task. Dr. Li significantly refined this machine. He created a molecular beam apparatus that functions like a super high-speed camera. It allowed him to literally see how energy is transferred and how chemical bonds break and form during an extremely brief reaction process. This fundamental discovery ushered in a new era of physical chemistry, providing us with a deeper molecular level understanding of chemical processes. After achieving global acclaim, Dr. Li made a moment decision. In 1994, he renounced his U.S. citizenship and returned to Taiwan to serve as the president of Academic Syndicat, Taiwan's foremost research institution. For 12 years, he dedicated himself to enhance Taiwan's research environment, successfully attracting many brilliant minds back home. He did not stop at science, he also active educational reform and social justice. Beyond Taiwan, he served as the president of the International Science Council, emphasizing the responsibility and scientists to address global challenges, particularly climate change and sustainable development. Dr. Li's story is a testament to the power of curious and the springs of dedication from meticulous experimental design in the lab to leading major academic institutions. His journey shows us that true scientific spirit is always connected to serving humanity and the homeland. That's all.
Hello everyone, My name is Yu Chongbo. My student ID is B143095019. Today, I will introduce a scientist, Charles Gao, as known the father of the fiber optics. He was a Chinese-British scientist whose groundbreaking theory on light transmission completely changed global communication. Because of his research, we can now enjoy fast internet, video calls, and data transmission across the world. Okay, let's see his early life and background. Charles Gao was born in Shanghai, China in 1933. He grew up in a well-educated family and removed to Hong Kong during his teenage years. Later, he went to London to study electrical engineering at the University of London. After graduation, he worked at Standard Telecommunication Laboratory in the United Kingdom. At that time, scientists knew that light could carry information, but no one knew how to send it over a long distance. The glass fiber then available were too impure. And how about his great discovery? In 1966, Charles Gao made a breakthrough discovery. He proposed that if the impurity in glass could be removed, light signal could travel through optical fiber over a long distance without losing strength. His idea was revolutionary. Most scientists at that time didn't believe it would work, but Charles Gao continued his research. A few years later, with improved glass fiber material, his theory was proven correct. His invention became the foundation of fiber optic communication, which today carry almost all of the world internet data, telephone call, and TV signal. Although it sounds easy, but it was not. Charles Gaus's work was not easy. At that time, most scientists thought the light could never travel far in glass fiber. Many people doubted his idea, and he had to convince engineers, physicists, and investors that his theory was possible. Despite this challenge, he continued experimenting with different types of glass and collaborated with material scientists to reduce impurity in the glass. His persistence finally paid off. The ultra-pure glass fiber was successfully created. And let's see his achievement and awards. For his outstanding contribution, Charles Gao received many international awards. In 2009, he was awarded the Nobel Prize in Physics for a pioneering work in fiber optic communication. He was also knighted by Queen Isabella II in 2010, becoming Sir Charles Gao. His work not only advanced science and technology, but also made information sharing faster and more efficient for everyone. Charles Gao passed away in 2018, but his legacy continues. Every time we browse the internet, watch online video, or make international phone calls, we are using his invention. In my opinion, I think Charles Gao is one of the greatest scientists of the modern era because he combined deep theoretical understanding with practical innovation. His persistence and creative thinking helped connect the entire world. He showed us that one great idea, supported by scientific theory, can truly change human history. Thank you.
Good morning, everyone. My name is Wang Zilun, and my student ID is B112030010. Today, I want to introduce a great scientist, Max Planck, and talk about his theories and contribution to modern physics. Max Planck was a German scientist. He was born on April 23, 1858 in Kiel, Germany, and passed away on October 4, 1947. He came from a family of scholars. His father was a law professor, and his grandfather and great-grandfather was also teachers. From a young age, Planck shows great talent in mathematics and music. He played piano and composed music. but later decided to study physics because he was fascinated by the law of nature. At the end of the 19th century, physics faced a big problem: the mystery of black-body radiation. Black-body radiation is the light and heat that an object gives off when it becomes hot. Scientists try to explain this using classical physics, but the equation predict infinity energy at a high frequency, something impossible. This failure was called the ultraviolet catastrophe. Planck wanted to fix this problem. After years of hard work, in 1900, he found a formula that perfectly matched the experiment data. But to make it work, he had to make a bold assumption: energy is not continuous, but comes in small packets called quanta. This idea was shocking at that time, but it successfully explained the black-body radiation and solved the catastrophe. To describe his idea, Planck creates the equation E equals h mu. In this equation, E means energy, h is Planck's constant, and mu means frequency. This equation means that energy depends on frequency. The higher the frequency, the greater the energy. Planck's constant becomes one of the most fundamental constants in all of physics. His idea inspired other scientists like Albert Einstein, who used it to explain the photon-electric effect, how light can knock electrons out of metals. This was the beginning of quantum physics, a new field that later changed our understanding of atoms, light, and matter. Max Planck's discovery changed the world of science forever. His series of energy quanta explained black-body radiation and opened the door to quantum physics. Because of his work, modern technology like semiconductors, lasers, and computers become possible. In 1918, Planck received the Nobel Prize in Physics for his groundbreaking discovery. In short, Max Planck was not only a brilliant scientist but also the man who started a new era in physics. Thank you for your listening.